Transaction tracing is essential for DevOps engineers to identify and resolve any performance-related issues in complex microservice application environments. However, once application complexity has increased beyond Hello World, the volume of trace data is way too large to allow the capture of every single trace. To contain the volume of trace data, sampling rules are used. These bucket traces by their entry point URL and specify what percentage of matching traces should be captured. This works okay for simple applications, but is far too coarse for microservices applications. Additionally, most traces that are captured are not so interesting, as they are executed perfectly. It's the ones where something went wrong that really should be captured. They are the ones required to identify issues. Here is an example of a call to checkout on an e-commerce application. It will take a different route across numerous microservices depending on a number of factors. For example, registered or guest user, discount code applied, payment method used. If only one of those possible routes is having performance issues and that route is not called as frequently as the other routes, the chance of capturing a trace of the issue happening is extremely small. To illustrate this, checkout with a discount code is only called 1% of the time. Of those calls with a discount code, only 10% are problematic. And finally, the sampling rule is only collecting 10% of all calls to checkout. The chance of capturing a trace of the issue is 10,000 to 1. Not great odds. Grepper's new technology can considerably improve those odds by using its signature sampling to bucket traces by their execution path rather than just the URL. Grepper collects all the spans that make up a trace, then automatically analyzes the trace execution path to create a fingerprint pattern. Using this technique, Grepper can individually baseline calls to checkout for registered users, guests, discount code, and different payment methods. Because it analyzes the complete end-to-end trace, it can detect errors at any part of the execution path and know if a particular trace fingerprint is slower than normal. This enables sophisticated sampling policies. Utilizing rules based on signature sampling dramatically reduces the volume of trace data sent to the observability platform, eliminating overage charges, while at the same time significantly increasing the signal-to-noise ratio by only forwarding complete traces with interesting data that are essential to diagnose application performance issues. Contact Grepper for a demo or sign up for a free trial. Go to our website at grepper.ai or scan the QR code.